Find the critical numbers for the function f of x is equal to x minus 2 sine of x. So critical numbers, once again, these are places where the derivative of the function is 0 or undefined, as long as those values where the function is 0 or undefined are in the domain of the original function. So if we take the derivative, we're going to get f prime of x is equal to 1 minus 2 times the cosine of x. Now, that can't ever be undefined, so we don't have to worry about that part. As a matter of fact, most of the functions you look at, you'll find that the derivative can't be undefined. But don't forget to look for it, because it does crop up once in a while. And if we just kind of begin to assume that we never have to worry about it, we're going to get in trouble sooner or later. So we're only going to need to consider the zeros. So let 0 be equal to 1 minus 2 cosine of x. That says 2 cosine of x is equal to 1 if we add 2 cosine x to both sides. And if we divide both sides by 2, cosine of x is equal to 1/2. So there are a lot of different places where the cosine of x is equal to 1/2. We'll just list a few. Generally in a problem like this, we probably would have given an interval over which to look for the critical numbers. But let's see if we can find a couple of them. We know there's one in the first quadrant, since the cosine here is 1/2. We can expect that one potential value, or one definite value, is going to be x is equal to pi over 3. We get a 1/2 there. And the cosine is also positive in the fourth quadrant, so we're also going to get one at 5 pi over 3. You can check those in your calculator if you like. Go ahead and take a look at the cosine of pi divided by 3. Make sure you get 1/2. I'm double checking myself here, but my calculator was in degree mode, so I was getting a funny answer. Make sure that you're in radian mode. If I take the cosine of pi divided by 3, I get exactly 1/2. If I take the cosine of 5 pi divided by 3, I also get a half. So those are going to be the only two places between 0 and 2 pi. We could add 2 pi or subtract 2 pi from either of these two values, and we can get a whole bunch more of these. But I think that gets the point across. And at least in the interval from 0 to 2 pi, these are going to be the two critical numbers for that original function, x minus 2 sine of x.